If you haven't done so yet, pause the video, reread the problem before listening on. We are asked in part A to calculate the intensity of a sound wave that is 3 meters away from the point source. Now, as long as we're assuming that we have a point source, and as long as we're assuming that the sound intensity is the same in all directions, then we can calculate the intensity at a particular distance from that point source by simply using this equation, in which r is the distance from that point source. Now the question gives us that distance. Again, it's 3 meters, and then the power is given to us in microwatts. So what we have to do for microwatts is simply convert it into watts by multiplying that value by 10 to the minus sixth. So that would give us the power in watts, and then we divide that by 4 pi times the distance, which is 3 meters squared. And when we do that, we can see that the intensity is approximately 8.84 times 10 to the minus 9, and then dimensionally we have divided a watt by a meters squared, so we would have watts per meter squared. So this is the correct answer to part A of the question. Now in part B, we are going to take that intensity and sort of convert it into a sound level in decibels. So here is the definition of sound level, which is symbolized by the Greek letter beta. We have 10 decibels multiplied by the logarithm of our sound intensity divided by some reference intensity. So all we need to do is plug in our intensity from part A in for the value of I, and then as far as the reference intensity is concerned, we typically use a reference intensity of 10 to the minus 12. Now, both of these intensities, again, are in watts per meter squared, but those units are going to cancel out anyways. So we just pick up our calculators and we punch this in, and we get a sound level of approximately 39.5, and then dimensionally, the only unit that's left over there is the decibels, and that is the correct answer to part B.